Live streaming is on.
Okay, morning everyone. We'll get started here in a couple minutes. I posted this article yesterday, and I also posted a video, and hopefully got a chance to watch the video. And if you didn't, you can go back and watch it after the lesson. So, like I said, I'll get started here in a minute or two. We're just going to read this article, and there's some questions to go with it. We'll start here in about 2 minutes. Okay, guys, I'm gonna go ahead and start here. So this is a reading on the Big Bang Theory, and this is kind of how scientists believe the Earth basically started. So it says almost all astronomers agree on the theory of the Big Bang, that the entire universe is spreading apart with distant galaxies speeding away from us in all directions. It says run the clock back 13.8 billion years ago, and everything in the cosmos started out as a single point in space. In an instant, everything expanded outward from that location, forming energy, atoms, eventually the stars and galaxies we see today. But to call this concept merely a theory is to misjudge the overwhelming amount of evidence. There are separate lines of evidence, each which independently point towards this as an origin story for our universe. The first came with the amazing discovery that almost galaxies are moving away from us. So it says in 1912, Vestos Silfer calculated the speed and direction of spiral nebulas by measuring the change in the wavelengths of light coming from them. He realized most of them were moving away from us. We now know these objects are galaxies, but a century ago, astronomers thought these vast collections of stars might actually be in the Milky Way. In 1924, Edwin Hubble figured out these galaxies are actually outside the Milky Way. He observed a special type of variable star that has direct relationship between its energy output and the time it takes to pulse its brightness. By finding these variable stars and their galaxies, he was able to calculate how far away they were. Hubble discovered that all these galaxies are outside our own Milky Way, millions of light years away. So if these galaxies are so far away and moving quickly away from us, this suggests the entire universe must have been located in a single point billions of years ago. The second line of evidence came from the abundance of elements we see around us. The earliest moments after the Big Bang, there was nothing more than hydrogen compressed into a tiny volume with crazy heat and pressure. The entire universe was acting like the core of a star, fusing hydrogen into helium and other elements. This is known as the Big Bang nucleosynthesis. As astronomers look out in the universe and measure the ratios of hydrogen, helium, and other trace elements, they exactly match what you would find if the entire universe was really once a big star. Line of evidence number 3, cosmic microwave background radiation. In the 1960s, Arno Penzias and Robert Wilson were experimenting with a 6-meter radio telescope and discovered a background radio emission that was coming from every direction in the sky, day or night. What they could tell, the entire sky measured a few degrees above absolute zero. Theorists predicted after the Big Bang there had been a tremendous release of radiation. Now, billions of years later, this radiation will be moving so fast away from us that the wavelength of this radiation will have been shifted from a visible light to a microwave background radiation we see today. The final evidence is the formation of galaxies and large-scale structures of the cosmos. About 10,000 years ago, after the Big Bang, the universe cooled to the point that gravitational attraction matter was the dominant form of energy density in the universe. The mass was able to collect together into first stars, galaxies, and eventually large-scale structures we across the universe today. There are known 4 pillars of the Big Bang, the 4 independent lines of evidence that build up one of the most influential, well-supported theories of all cosmology. But there are more lines of evidence. There are fluctuations in cosmic microwave background radiation. We don't see any stars older than 13.8 billion years. Discoveries of dark matter and dark energy, along with how light curves from distant supernova. Even though it's a theory, we should regard the same way we regard gravity, evolution, and general relativity. We have a pretty good idea of what's going on. We've come up with a good way to understand and explain it. As time progresses, we'll come up with more inventive experiments to throw at it. We'll refine understanding, and the theory goes along with it. Most importantly, we have confidence when talking about what we know in the early stages of our magnificent universe and why we understand it to be true. So, kind of what this is saying, you guys, is everything started like kind of a single point. There was this big explosion. All this gas came out. Stars came out. It was really hot. Then eventually it cooled. When it cooled, that's when we got our oceans. We got our land masses, the mountains, valleys, deserts. All that came about from all these elements, cooling down, water even more, in the mountains and things like that. But I think it all started from a single point, like it said, 13.8 billion years ago. There was an explosion, and it just basically, and you guys know an explosion, everything's going everywhere. So that's kind of what the Big Bang Theory is in a nutshell. And it says, so what evidence is there for the Big Bang? So all galaxies are moving away from us. And that's the explosion. When explosion happens, everything moves away. Similar, like if you get in a car accident, the glass starts flying in every direction. Okay, and that's kind of the same thing. So basically, that's one thing. And then it said, Vestos Siffler calculated the speed and direction of spiral nebulans by measuring the change in wavelengths light coming from them. So basically everything is moving away. And then Hubble discovered the galaxies outside of our Milky Way. So there's stars outside of our own Milky Way. That supports everything is kind of moving away from that initial explosion. So he thinks that basically everything was located together, one small point. And when you look up in the sky at night, if you see all those stars, we know basically the planets and everything they think is moving away from us. And astronomers look out in the universe, I'm down right here, and measure ratios of hydrogen, helium, and other traces. They exactly match what you expect to see if the entire universe was once a big star. That star released all these gases. Okay, that's kind of another thing. The last one is, or number 3, excuse me. They talked about basically the radio emission that was coming from every direction in the sky, day or night. What they can tell, the entire sky measured a few degrees above absolute zero. So absolute zero is really cold, so it's a little bit warmer. And the radiation, you guys, we get radiation from the sun. That's kind of what heats us, and that's kind of an example of this. And the last one talks about what I talked about at the beginning. The universe cooled to a point that gravitational attraction matter was dominant in the form of energy and density. Mass was able to collect together in the first stars, galaxy, and eventually large-scale structures we see across the universe today. And those are, like I said, the mountains, the planets, things like that. Okay. So the Big Bang Theory, there's kind of 4 pieces of evidence. And I want to go down to just these 4 questions. So it says, asteroids, small bodies in space, have collided with Earth many times. The best known strike occurred about 65 million years ago and created a huge crater in the Gulf of Mexico. After striking the Earth, the asteroid likely caused huge tsunamis and waves thousands of feet high. Dust particles probably filled the air. Scientists believe dust blocks sunlight, eventually causing the plant to cool. Lack of sunlight may also affect plant life, which possibly killed most dinosaurs. A more recent large asteroid happened in 1908 in Siberia, Russia. As the asteroid exploded, it scorched and leveled trees miles around. For several months afterwards, astronomers reported increased dust in the Earth's atmosphere. Today, scientists around the world track asteroid movement. When astronomers discover a new asteroid, they photograph it over several days. They use the pictures to create computer models of its possible orbits. Next, they compare those orbits to Earth. Based on the comparisons, they try to determine how close to the Earth the asteroid must pass. Scientists have created a Toronto scale, which measures how likely it is the asteroid will collide with Earth in the next 100 years. The scale goes from 0, probably no, to 10, definitely impact. In 2004, astronomers observed an asteroid they named 2004 MN4. They predicted it would pass near Earth in 2029 and gave it a rating of 4 on the Toronto scale. After studying for several months, they decided the asteroid would not strike Earth and changed the rating to 0. Okay. So this asks about the rating here. Number 1, which of these do scientists think happened last after the asteroid fell on the Gulf of Mexico? So if you go up to that, the last thing that basically happened, it says, after striking the Earth, the asteroid caused huge tsunamis or waves thousands of feet high. Dust particles probably filled the air. Scientists believe the dust blocked the sunlight, eventually causing the plant to cool. Lack of sunlight may also affect the plant life. So basically the last thing would be B, the planet cooled. Okay. Number 2, when astronomers discover a new asteroid, they first, so it says, today scientists around the world track asteroid movement. When astronomers discover a new asteroid, they photograph it over several days. Okay, so the first thing they do is they take pictures of it, which would be A. So number 3 says, after astronomers create computer models, the asteroid orbit, they they basically, if you go, they use the pictures to create computer models of its possible orbits. Next, they compare those orbits to the Earth orbits. So it says after they create computer models, they try to determine how close to the Earth the asteroid might pass. So that would be, number 3 would be, after they take pictures, they kind of compare it to the Earth's orbits. That would be D. And number 4, when astronomers discovered that asteroid 2004 MN4, which of these things happened first? So it says, in 2004, astronomers observed the asteroid they named 2004 MN4. They predicted it would pass near Earth in 2009, gave it a rating of 4. So the first thing they did is they predicted it would pass near Earth, which is letter A. Okay, so this is some of the stuff that we did when test preparation. So you'd read this paragraph, and then these 4 questions basically all have to do with that paragraph. Okay, I just gave you the answers, and if you were struggling, once again, the thing I would suggest is you kind of, cross ones out that aren't right. Okay, so that's it for science today. We will next week on Tuesday do another science lesson. We're going to continue to do earth science. And if you haven't done so, I mentioned at the beginning, I would encourage you to go to that video, The Big Bang Theory, and that explains kind of this a little bit more. If you didn't quite understand the reading, the video will give you kind of some more information. It might be a little easier to understand. Okay, guys, have a great day. I'll be doing reading here very shortly, and I'll send out a link for that. Okay.